Hello, welcome to GMAS classes. I've come here today, the second video on Class 10 Mathematics Chapter 1 Real Numbers. The previous video we had seen the fundamental theorem of arithmetic and definitions of real numbers, etc. Now, the fundamental theorem of arithmetic, I'll repeat. We are going to apply it today. So I'll repeat the fundamental theorem of arithmetic. Every composite number can be expressed as the product of prime numbers, and this prime factorization is unique except from the order in which they occur or the prime numbers occur. We are going to apply this in exercise 1 of the chapter Real Numbers. In the first exercise, question number 1 is express the numbers as a product of prime factors. Very simple. Let's take the first question, 140. 140 is a composite number. We are going to express it as the product of primes. We have to factorize the composite number 140. 140 is divisible by 2. So first we are taking the prime number 2. This is when you divide 140 by 2, you are getting 70. Then again by 2, you are getting 35. 35 is not divisible by 2 anymore. So let's see whether it is divisible by 3. The test of divisibility by 3 is 3 plus 5, 8. 8 is not a multiple of 3. So we have to go to the next prime number 5. This 35 is divisible by 5. 5 7s are 35. The next prime number is 7. 7 1s are 7. So the composite number 140 can be written as 2 into 2 into 5 into 7. Or you can write it as 2 to the power of 2 into 5 into 7. This is the prime factorization. Now let's take one more number. Second question or second part of the first question, 156. 156, again when you take the factors, you can divide this 156 by 2, you are getting 78. Then again by 2, you will get 39. Then again by 3, you will get 13, and 13 is a prime number, so you will get 1. So 156 can be written as 2 into 2 into 3 into 13. Now, let's go for taking another bigger number, the part D of question number 1, 5005. Now 5005, first you can see whether it's divisible by 2. This is not divisible by 2. This is neither divisible by 3. So let's go to the next prime number 5. Since the units place has got 5, definitely this number will be divisible by 5. When you are dividing 5005 with 5, you will get 5 ones are 5, 0, 0 and 1. Now, this is no more divisible by 5. Then let's go to the next number 7. Let's see whether it's divisible by 7. 7 ones are 7. 3 is remaining here. 3, 0, 30. 7 fours are 28. 2 are remaining. 2, 1, 21. 7 threes are 21. Now, this number is not anymore divisible by 7. So let's go to the next prime number 11. 11 ones are 11. Then 3 is left. 33. 11 threes are 33. Then you got 13. 13 is a prime number. So it's dividing by 13. So the number 5005 can be written as 5 into 7 into 11 into 13. Now you can write this in any order. There is no harm. That's what the fundamental theorem of arithmetic says. Like here I have taken 5 first. You could have taken 7, then 5, then 13, then 11. So only the order can change. But whatever order you take, your factors will be the same. 5 into 7 into 11 into 13. This is the fundamental theorem of arithmetic. Let's take one more number, the last part, 7,429. 7,429, you have to start testing it by 2, the prime numbers 2, 3, 4, 2, 3, 5, 7, 11, etc. Then this was quite a big number and it was not divisible by 2, 3, 5, 7, etc. I directly had to go to 17. 17 fours are 68, then 6 remaining 62. 17 threes are 51. Then you are getting 119. Then 17 sevens are 119. Then this I checked again. This is no more divisible by 17. So I am going to the next prime number 19. 19 twos are 38. Then 5 remaining 5, 7, 57. 19 threes are 57. Now you got 23. 23 is a prime number by itself. So 23 ones are 23. So the number 7,429. This is a composite number. It can be written as the product of the prime numbers, that is 17 into 19 into 23. I hope you all have understood how to take the prime numbers, prime factors, or the factorization, how to do it. Now let's go to question number 2. Here the question number 2 is, find the LCM and HCF of the pairs of integers and verify that LCM into HCF is the product of the two numbers. This property we have studied it in the earlier classes as well. Let's try to find out whether this property holds good or not. The property is HCF into LCM of any two numbers is the product of these two numbers. Let's take the first question. The two numbers are 26 and 91. 26 can be factorized as 2 into 13. So, and 91 I have factorized as 17 into 13. So, what is the LCM of 26 and 91? 2 into 13 into 7. You are getting 182. Now, the highest common factor HCF of the same two numbers 26 and 91 is 13. Now, let's try to find out the product of HCF and LCM. That is 182 multiplied by 13. We are getting 2366. Now, what do we have to do? We have to verify that this 2366 is the same as the product of these two given numbers. What are the two given numbers? 26 and 91. Let's multiply 26 and 91. We are again getting 2366. So, here we have proved that the product of HCF and LCM of 26 and 91 is the same as the product of these two numbers, that is 26 into 91. Have you all understood this? Now let's take one more pair of numbers. 510 and 92. I'm taking the prime factorization of 510. I'm dividing it by 2 first because this number is divisible by 2. So I will be getting 2 2s are 4, then 1 11, then 2 5s are 10, then again 10, 2 5s are 10. Now this 255 is no more divisible by 2. So I've taken 3 now because 5 plus 2 is 12. 12 is a multiple of 3. That means this 255 is divisible by 3. So when I divide this 255 by 3, I am getting 85. When this 85, 8 plus 5 is 13. 13 is not a multiple of 3, so it is no more divisible by 3. So, but this is very clearly The ones place has got 5, so it is divisible by 5. So 5 17s are 85, and 17 is a prime number, so you're getting 17 ones are 17. So 510 can be written as 2 into 3 into 5 into 17. Now let's take the prime factorization of 92. 92 is divisible by 2. When you divide 92 by 2, we are getting 46. And 46 is again divisible by 2. We are getting 23. 23 is a prime number. So 23 ones are 23. So 92 can be written as 2 into 2 into 23. Now the LCM of 512 and 92 will be 2 into 2 into 3 into 5 into 17 into 23. That is 23,460 you are getting when you multiply all these. Now, HCF of 510 and 92 is, you can see the factors, only one factor is common here, 2. So, HCF of the highest common factor here is 2. Now, let's find the product of LCM and HCF. LCM was 23,460 into or multiplied by the HCF is 2. We are getting 46,920. Now, let's try to find out the product of 510 and 92. I multiplied 510 by 92. We are getting 46,920, same as the product of HCF and LCM. So once again we proved that LCM into HCF is equal to the product of the two numbers. Now let's move on to question number 3. Find LCM and HCF of the following integers by applying the prime factorization method. The same way we have to factorize, that's all. Here you don't have to find the product. No, you only have to find the LCM and HCF. 12, 15, 21. I've taken the prime factorization of 12, that is 2 into 2 into 3. Now the prime factorization of 15, that is 3 into 5. Then the third number is 21, prime factorization of 21, we will get it as 3 into 7. So the LCM is the least common multiple is 2 into 2 into 3 into 5 into 7. 2 into 3, 2 into 2 into 3 into 5 into 7, you are getting 420. So 420 is the LCM of 12, 15 and 21. Now, the highest common factor HCF is, you can see that there are only 3 as the common factor here. 2's are here in the first number, but in the second and third, 2's are not there. 5 is there in the second number, but it is not present as a factor on 12 and 21. And again, 7 is a factor of 21, but 7 is not there in the factors of 12 and 15. So here you can find that only 3 is coming as the common factor. So the highest common factor is 3. Now let's go to another part of the same question. 8, 9 and 25. The factors of 8, we can do it even mentally. 2 into 2 into 2. Then 9. Again we can do it mentally as 3 into 3. 3 3's are 9. 25 is again another very simple number. 5 into 5, 25. Now let's see what is the LCM of 8, 9 and 25. The LCM, you have to take all these numbers, 2 into 2 into 2, into 3 into 3, into 5 into 5. So you are getting, when you multiply all this, you will be getting 1,800. Now let's come to the highest common factor, HCF. See here, this can be written as 2 into 2 into 2 into 1 because 1 is a factor of all the numbers. So, only 1 is coming as the common factor in 8, 9 and 21. Therefore, the HCF of these three numbers is 1. Very simple, right? Now, given that, the next question, given that HCF of 306 and 657 is equal to 9, highest common factor is given. Find LCM of 306 and 657. That is, HCF of two numbers is given. We have to find the LCM. This is a very simple question because we have just now proved the property that HCF into LCM of any two numbers is equal to the product of the given two numbers. So, here HCF of 306 and 657 is given to be equal to 9. What is the LCM of 306, 657 is equal to what? This is the question. So we can use the property HCF into LCM is equal to the product of the given numbers. So, in the place of HCF, you can put 9 into LCM is equal to product of the given two numbers. The given two numbers are 306 into 657. So, in order to find LCM, you will have 306 multiplied by 607 and you can transpose this 9 to the other side, so you'll get upon 9. Here, you have to multiply these two numbers and divide it by 9. Here, an easier way is that by multiplying these numbers, it will take time, then again you are going to divide it by 9. Here, if you write like this, you can directly do this if this is divisible by 9. 3 plus 0 plus 6 is 9. 9 is a multiple of 9. That means this 306 is a multiple of 9. So 9 ones are 9. 9 threes are 27. 3 remaining here 36. 9 fours are 36. So you are getting 34 into 657. This way you can reduce the time of multiplication. When you multiply these two numbers in the beginning, you will get a bigger number. Again you are going to divide it by 9. So it is more time taking. So if you can simplify these numbers in the beginning, then multiply it, it will be easier. So 657 should be multiplied by 34. 7 fours are 28, carry 2. 5 fours are 20 plus 2, 22. Carry 2 again. 6 fours are 24 plus 2, 26. Now let's multiply by 3. 7 threes are 21, carry 2. 5 threes are 15, plus 2, 17, carry 1. 6 threes are 18, plus 1, 19. 8, 3, 13, carry 1, 12, 2. 22,338 is the LCM of these two numbers. Let's see it once again. HCF of 306 and 657 is given as 9. LCM of 306 and 657 is asked. So we can use the property HCF multiplied by LCM is equal to the product of the two given numbers. So in the place of HCF, you can directly substitute 9 because it's already given. So 9 into LCM is equal to 306 into 657. So we have to find LCM is equal to 306 into 657. This 9 should be transposed to the other side. It will come upon 9. And these two can be simplified. 9 3s are 27. 3 remaining 36. It becomes 36. 9 4s are 36. So the numbers left out is 34 into 657. 657 into 34 will give you 2628. Then plus, when you multiply the same number by 3, you are getting 1971. When you add, you will get 22,338. Yes, that's all. So the LCM of the two numbers is 22,338. Now we are going to move on to question number 5. Question number 5 is, check whether 6 to the power of n can end with the digit 0 for any natural number n. That is, if you replace n by any natural number, will this positive integer end with 0 or not? Here, 6 to the power of n can be written as 2 into 3 whole to the power of n, or 2 to the power of n into 3 to the power of n. For any number to end with 0, then the number must have 5 as one of its factors. Here we can see that 6 to the power of n has factors 2 and 3 and not 5. Therefore, we can say that 6 to the power of n cannot end with 0. This property here is very important, that for any positive integer to end with the digit 0, it must have 5 as one of its prime factors. Please remember that. Then, in this case, 6 to the power of n have factors only 2 and 3 and not 5. Therefore, 6 to the power of n cannot end with 0 for any positive integer n. I hope it's clear to you. Now we are moving on to question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Look at the first one. 7 into 11 into 13 plus 13. Here you can see that in this term we have 13 as the common factor. Here also there is 13, here also there is 13. So 13 is the common factor. So it can be written as 13 into 7 into 11 into 1 plus 1. That's equal to 13 into 78. So this number has got 13 as a factor other than 1 and the number itself. In the same way, the second part, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. If you observe the number carefully, you can see that 5 is a common factor here. So if we take 5 as the common factor, we have 7 into 6 into 4 into 3 into 2 into 1 plus 1. This is equal to 5 into, if you multiply 7 into 6 into 4 into 3 into 2 into 1, we are getting 1008 plus this one is 1009. So here again we can see that this has got 5 as a factor other than the number and 1. That is, the number itself and 1. Other than these two, it has got 5 as a factor. So, this is also a composite number. I hope everything is clear to you. Now, we are going to move on to the next question. The next question is, there is a circular path around the sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Both of them are taking round of the same field. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Definitely, because their speeds are different or their time they are taking is different. They may be running in different pace, but at some point of time they will meet again at the starting point. Here, in order to find the time after which they will meet again at the same point, same starting point will be given by or will be calculated by the number of minutes by the LCM of 12 and 18. LCM of 12 and 18 is 2 2s are 4, 3s are 12, 3s are 36. 36. So, Sonia and Ravi will be meeting again at the starting point in 36 minutes. Though the time taken by both of them are different, they will be running at different pace, but still, after a particular time, in this question, after 36 minutes, they will again be meeting at the starting point. That is, you have to find out the LCM of 12 and 18. So, here ends the first exercise of the chapter Real Numbers. I am sure everything is clear to you. Now, you must practice all these. You must do some extra questions as well. So, in the end of this, after finishing the next exercise also, I will give you some extra questions for practice. And practice is a must for you to be thorough with the chapter. So, good luck.